This right here is a record. This right here is a class. Now, if you look at these two, they look very, very similar. Actually, their declarations look identical. T user rec equal to record, and then we have our properties here. You can see they are our variables for properties. They are our properties. Here is our constructor, our record, and here is our toString function. Exact same thing for our class. You can see here are the declarations for our record and our class. So here are our functions. Come down here, created our constants for our name and our age. We've created these, or we've created variables for these, and call our class constructor. Here we call our record constructor. Here we write the output of our toString function to the command line. So let's begin. Let's first start talking about records. Records are a Delphi. Sections of this video got cut a little bit because the audio was not completely clear. So I'm going to explain this little part here. So what I was saying here is that a record and a class are collection data types. At least I'd call them collection data types, which collect values, which we represent as properties, which collect constructors. Now, not necessarily collect, but then they collect functions and they collect data. So data as in these variables, these properties that kind of, in my mind, represent these variables and our functions. So our functions like toString right here and our constructor. So that's what I was trying to say, that these are collection data types which collect bits of data together, and we can structure them in any way that we want to use that data in the way that we want, right? There may be use cases where we want to store and collect data on users and use them in a particular way. That's why we order them in a struct. That's why we have fields which apply to certain properties of that thing. That's why we have functions which do certain things to that thing, or use that thing, use that data that we're storing in the struct to do things that are useful to us. And of course, we use them very often in programs to store data dynamically and in large amounts. Say you want to store user data, you'd use a class, right? We have this user class right here with all of our data in this class. And of course, we can add other stuff. We can add heights, we can add weights. There's a lot of different stuff that we can put into a class or a record. But there are differences between classes and records. So let's start getting into those. So here we have our little example here. I've created a breakpoint here, begin statement, so we can watch our code as it executes. So if I hit run, so we can see in our debugger, I guess, tabs, if we look at our local variables, all of these have not been signed yet. So we start moving, stepping through our code, and you can see our name has been created, age has been created. We've declared our variables, and now here's where the first important difference between classes and records begins. In this video, I'm not going to focus on the all the theory differences, as in all of the in-depth differences between them, how they work and such. I want to show a practical difference between records and classes. So if we look at here, come here to our local variables table, what I call a table, we have our user class and user rec. Now here's the first important thing to know. Our user class, we haven't called the constructor yet, just on that line. And if we into this function, we come and go step into, we create our user class. Step over, step over, step over, and now it has a value. But if you looked a bit earlier, the value was nil. If I come here again, do some stepping over, our user class, or the value of our user class is nil. We look at our fname and fage, they're inaccessible values. Now, if we come to our record, they aren't. We have not called our constructor yet. Our records constructor has not been called yet. Our data has been given values already. So these are just, I'll call them default values. This is just terminology I'm coming up with from using Rust and like default value terminology. So these are default values. Fname is an empty string, fage is 0. And our user class, in our user class, that's not the case. Step over, they suddenly exist. Fname has a value, fage has a value. If we write to the console, as you can see, user Daru age plus 20. That's just a bit of output to show us what's going on. And if we come over here, we've already created our record, and now we call the toString function. Come over here. We should see some display, but we aren't for some reason. Let's try that again. Then past that, there we go. And there we are. The records data has been shown. Now, what if we did not call the constructor? So from what you saw, remember what we saw in our local variables table? When we didn't call the constructor, our class had no data. It was assigned to nil. The value of the class was nil. So this object had a nil value. If I comment this and comment this, and I come back again, you can see we are on inaccessible values because we haven't entered the main function. We enter name and age have default values. Then when we step over, they suddenly have values. We commented this line, so we'll jump that. User class is nil. We call toString access violation. We hit break. Our trace brings us here. And why does it bring us here? Well, it's because we tried to call a function which accessed name age, but name and age, oh, that's where that plus came from. Name and age were given nil values. They were inaccessible values. because we have not created our class. Now, if we ignore that, we just say, okay, that's cool. That's just a result of what we tried to do. We do not need to look at the assembly right now. And I do hope to kind of make a video about assembly in Delphi. At least about analyzing assembly in Delphi, because I think that's a useful thing to do sometimes. So actually, let's skip this function because it'll create the same error twice. Actually, we don't need to do step over, step over. Of course, there's our access violation. Oh, it'll start from 0. Okay. Comment that line. Now, what happens when we call this function on our record? No access value. Now our output is user empty string age plus 0. And why is that? Because our record, at least these properties, these variables, which are all properties in our record, have been given data, but not, I guess, useful data, right? They've just been given empty strings. Now, if we come over here, we don't call the constructor, but let's say we just wanted to assign the value. So we said user class.age and age name. Let's do that. I do kind of dislike how we declare how we assign variables or values to variables in Delphi, but that's just a small little gripe. Enter debug mode. Now here's something interesting. We get the same issue. Break. Our error is right here. We tried to assign a value without creating the object. Now, what if we did that here? User rec age, so rec name, trying to name, come back in, move through, first access violation. Oh, it's not going to let me continue. Comment those lines. We move through our code, and now, unlike our class, we tried to assign a variable to any of these properties in our class. We got an instantaneous access violation. But here, our record was assigned the data we assigned it. So if we step over at our output, there we go. And we did not get any access violation errors. Now, of course, when you're using classes, you usually will. And another thing about using classes is that we have normally you have to free our classes. If you want to free your class shortly after using it, normally you create a class and then you'd say try use your class and then free. So there we've used our class and now we freed it. Now this will just the free function will free any accumulated heap data from the class. Now that's not something you need to worry about. What I mean by heap data is just data that's been allocated to the class dynamically. That's why when we moved past the free function, Not sure if you saw it. Over here again, create. Our name has a value called free, and the name's value is gone. That's because the string is a heap allocated piece of data that gets freed from the heap when we call free. That's not stuff that's really necessary to know, but I think it's great to know. Stack allocated data and heap allocated data, because there are differences between them, and I think they're great to know. Now, if I try to do the same thing here, finally set user rec free, there is no free function or free procedure or free method, whatever you're going to call it. The method of our record. This is because default records do not have constructors and do not have destructors. In my mind, they're allocated the second they're created. But classes, on the other hand, need constructors and by default have destructors. So a class will almost always have, or I think always have, a free method. You always need a way to free your class. But records do not have such, right? With a record, you do not need a constructor, right? I could remove this entire line right here, use this record, and we'd still be free to use it exactly the same way that we would use this class right here, right? We can use these two interchangeably in many places. Now, normally we are to use classes, and I do understand why, because the way records and classes are allocated is a bit different. I'm not going to get into that. I'll link a documentation page which explains records, and then I'll also link one which explains classes, which will explain those differences between how they are created, because there are differences between records and classes that make this possible. So in terms of records, I normally recommend, that's just my thoughts on records and classes, I normally recommend records for data that is not dynamic, let me say. Data that you don't want to constantly change and pass around, or data which is like, I'll call it quote unquote big data. I mean, yes, data that is in high quantities. As if we added another variable here, let's just call it f-words. Made this exist. Think no, no. Now there's a certain unit where we can find the string list. Yeah, classes. System.classes. There's our string list. Words. String list. Read. Writes. So here we create a string list. Now a string list is class. So it's a dynamically allocated class because it is a list of strings. So a string list is a class, which an object class which stores lists of strings which you can push to, much like string builders in Java, where you can have a list of strings which you just push new lines to. So we say And then here we just convert our string list to a string. Then we do the same thing here. I'm going to illustrate two different things here. We run, start moving through, create our class, and we want to add something to our words list, access violation. Why do we have an access violation? Because string list is an object class, much like this class right here. The string list, which is a property of this class, also needs to be created. So we say words assigned to t string list dot create. Now, it's also good to not make the mistake of doing this, saying words dot create. You create a data, you create a variable of a class data type by assigning it to class dot create, not variable dot create. Then we do the same thing here. Now, this is where I would recommend class. Now, it's not because of something the record can't do, but it's because of something that using a record may make you miss. So we come over here. Now, when we call our constructor, our list is created. Then we add something to our list. Come to F words. Look at the list of our words. There's our words. We call write_ln. That's a bit odd. Oh wait, we haven't actually called. No, we have called the function. Let's try that again. Now we've written. Yeah, that's a little bit odd. Probably look into why that's happening. Oh, right. Look into why that's happening. But as you can see, no access violation. And if we look in here, our word has been added to the string list. Of course, if we do the same thing with our record, now keep in mind that our f words variable is assigned to nil right now, and the value is nil. Create it, and boom, we have some data. We add something to f words, and now f words has something as its first, one of its words. Of course, we have another piece of output right here. Now, one thing that a record does not do well in this situation, I run this again, create our class. Now our class has been created. We pass through the free function. Look into f words. Oh, usually destructor so here's our destructor for our class. So usually when you create a class, you would also be recommended to have a destructor. Destroy, and then here we just call words dot, which will free the words variable when we call free from our destructor. Okay, that was not destroyed. So let's use destroy instead. move in. Okay, me and destroy don't seem to do the same thing. Yes, that is a point of research for me. But what I was trying to illustrate here is that normally when you have classes which inherit other classes as okay, was not destroyed. That's a bit upsetting. When you have classes that inherit other classes as properties, you will rather when we call class.free, it frees all the accumulated data of that class and calls the destructor, which you can customize by overloading. You can either overload or you can that's why. Overload, override. Override, not overload. Hmm. Okay, having trouble creating our destructor. Normally, when you create a destructor, it should free all the data accumulated by your class. So if you have another class inherited by your class, like our string list that we created, that we assigned, that we declared here, when you call free or you call destroy, this, as long as you've set it up correctly, you would be doing it as well. But when you use a record, you usually, at least in my mind, you wouldn't think of that because you wouldn't need to use the constructor. You can skip the constructor step entirely, create this on its own, so you don't need to or create. You can just do this. Or you can do this with classes as well, but you need to call the constructor of the class first. So string list dot create. Now we're not obliged to free this. There's no try method which we'd use here to like say try and then use the class and then finally we free it, because there is no free method, there is no create method. You can create your own free method if you want to release any accumulated memory that you would have accumulated using your record. So if you're using any dynamically allocated data type like a string list, like JSON values, like strings and other classes, you'd want to free them because some of them accumulate large amounts of memory and you want to free that memory when you don't need it anymore. Yeah, we're not obliged to call the free method. And normally the free method is called when your program finishes execution. But there are times when you want to free it, but you don't. Now you have a variable that's been dynamically allocated that is not going to be freed until your program either stops execution or you leave whatever function or unit that declared that data type. Hello, it's future me in editing again. I want to add a little bit more stuff to my talk about freeing objects. So I'm also going to link the article with the article documenting the free function, but basically what the free function does is that it calls, rather it frees all the memory that the current object holds, and then if these fields here, these components here are owned by the class, then free will be called on them as well. And then that's why when we executed our program, then we stepped through. As you can see, our name in the user class is assigned to Daru, but then when we call free, it's gone because that name string has been freed from memory. And if we wanted to free this, we would explicitly call free for it. It's not necessarily owned by the class, but of course, when we move, it disappears because now that we've called the free function, the memory which this item here, this object, once used, has now been reallocated to this record right here. So normally we want to call free on everything that our class owns, unless it's an integer, because integers are stored on the stack and we don't really need to worry about those most of the time, right? Maybe we may have different cases where integers are also included, but you don't normally free integers, and strings are freed automatically. But for every object, like a string list, you usually want to call free on that as well. Now, of course, here the string list was freed because free is called on everything this class owns. But if this class had an object that it didn't necessarily own, that maybe it inherited from another class, right, that is owned by another class, and we wanted to free that too, then we would call free on that item itself, right? Here we would, let's get out of execution. Here we would call user class dot words dot free, and then that would free this object from memory. Now, of course, as I said, because this is a property of the class, it is freed automatically. But if it was gotten, or rather obtained or passed from a different owner, and that owner still owns it, it's just kind of, in my mind, borrowing that object, then we would have to explicitly call free on it. And like I said, I'm going to link the article, the documentation, where the free function is explained a little bit more in depth, but that is a gist of what happens when you free an object from memory. This is where I find classes too. When you have data that is owned by other data, when you have a class which owns other objects, like an object class which owns other object classes, because oftentimes when you create a record, or at least me, when I create a record, I don't think about creating it or anything, or using a constructor, because I don't normally need to. If I come to a project of mine over here that I've been working on, so let's save this. Then we open up this project. Oh, well, I didn't have to save that. Come over here. Here is a record that I'm using in this project. Stores a bunch of functions that refer to each other. So these three functions refer to this one function, which calls this function when our log file doesn't exist. And this is a record. So we're free to call these functions because we don't need to declare, or rather, we don't need to call the records constructor. It doesn't even have one. But if this were a class, we would have to use the constructor before we used the record. And this is where my thoughts on the differences between these two come in. Records are great when you want to store a bunch of data, but you don't care about what size it is. You don't care about what it's storing. rather you do care about what it's storing, but you don't care about it being dynamically allocated. You don't really need to think about creating it or destroying it. Maybe you'll use a constructor, but you don't have to. The class, you need to create the constructor, because the constructor is a virtual method of every class, right? Every class has a constructor as its virtual method. So if you do not call that constructor, the object will not be created, right? This object will not be, it will not be given a value. As you saw in our examples, it'll be given nil as its value. But if you look at records, it's not the case. We can create it, and our variables will basically automatically be given data type. Be given data. It'll be default data, it'll be nil data, but they'll be given data unless there are other classes within, or rather classes within records do not get are called default declarations, because then that would mean that the constructor of the record was called when the record was declared, and that would mean a function was kind of run in the background, and you don't normally want a function being run in the background without you knowing it's being run, unless it's some really specific kind of function. But in this situation, it's a constructor for something you normally want to call that yourself, so you know that it's been created. So those are the places where I find differences between records and classes. There are links in the description that go in depth on documentation that go in depth on the differences between these two, and I hope to write an article, a blog article describing these differences. I'll add a link to my blog page if you want to look, if you want to read through that article instead of moving through all of this rambling, and if you just want to gain a better understanding of it, you can check that out when it's out. So that's those are records in Delphi. They are, in my mind, the alternative to C structs. They can do what classes do, not necessarily better, just differently. They store data much like classes, but then they don't have constructors by default. When you assign strings or integers or any kind of data type to a record, they do not need to be, I guess, coupled with the constructor, right? You can assign them on the fly, but with a class, you need to assign them in the constructor, or at least create it and then start assigning afterwards. But you cannot use a class, as far as I know, until you have called its constructor. Record, you can use it without calling the constructor. You will not be, I guess, penalized. When I say penalized, I just mean that you won't get an access violation error. Of course, if you try to use a record that contains object that has not been created, you will get another error, because you're trying to use something that hasn't been created. It's not the record itself, but it's a constituent of that record. So I hope you found this video useful. I thought valuable to create a distinction between classes and records, and to explain my own thoughts on records, where I think you should use records, why I think you should use records when the situation is right, and when you should use classes, right? Records for storing methods and data, where the size doesn't really matter that much to you, but then classes when the data and its size is important. You want to be able to you just kind of want to be forced to create the constructor and forced to create the destructor, because those things are just great reminders to handle your data, control your memory, because that's very important. So thank you for watching. See you in my next video.